scenes we have in here. Okay, yeah, this is what we got here. Shall we see how fast it runs actually? That's real time on 16 processor cores, which is not too many, but that's like ridiculously fast for an engineering simulation. So let's see, is it single layer? Ah, yes, it's just deforming. Towel index, okay, that's interesting. Okay. And now the machine is starting to turn. Okay, that's wonderful. So that's where we start working. Scalar towel. Let's maybe switch towel to... Oh, we have contact force. That seems a little bit boring. Particle velocity magnitude. Let's start with that. Not radiation spectrum, please. I'm not sure about that. Okay, let's start with the easy parts. What's that here, brother? 16 by 9 it needs to be. It's always 16 by 9. We don't need no annotations. We don't need no axis. Bond, bug detection. We have no bugs. Okay. Okay, the scalar field will be 0 to, no, maybe not 0. Three meters per second, maybe 0.03. So we can use a log scale later, maybe. And we have 512. Yes, that's better. So let's let it run a few iterations maybe. What's our time step, by the way? Towel interval time. That's interesting. I guess we need to make it slower. Just to implicit unsteady. TS is my parameter. TS. Oh no, that's fine. That's fine. That's actually fine. Uh-huh. Let's see what happens if we turn it, just turn it to log scale. No, that's the wrong way. Okay. What do we need to do? Obviously, there is some artifacts here which we need to get rid of. This looks like overlapping geometry. We need to make some glass in front. We need to make the drum metal. Surface front will be 1. And it will be preset material. And the preset material will be transparent body. Well, it's not glass actually what it will be in the end. Maybe it will be. So let's see. What I want to see why I let this simulation run is how fast are these going? Please don't just fill up my... There's like nothing. It has like, it doesn't use any disk space. So it stays below 3 meters per second, right? 2.5 is the highest we can see. So we say it's 2.5 here. And 0.5 maybe here. Okay. Isn't that a little bit boring if I always use this color bar? Maybe we should use something different today. This one should be reversed then. Yes, we can turn this into Siemens maybe. What do you think? This one needs a brighter one at the end. But apart from that, it should work. Oh, I'm not satisfied with it. Really not. Sorry for that. So let's go with and stick with that first until something better comes up. What is this? That's wonderful. Gonna take this one here. That's almost indigo that we had before. Okay. So, scalar contacts. Why is it so big? Scalar function. Can I make contact force here? What do we have in here? P. That's contacts between. That's phase interactions. Okay, nice. Let's take the wall contact interactions and make them contact contact relative velocity. Does this make sense? No. Okay. So let's make this one here 6e, 5e minus 6. And this one here 1e minus 8. And the color bar, yeah, let's work on the color bar later. So, scalar towels. These are my contacts now. I want my contacts to light the scene. But it seems like the contact overlap is not suitable for this. Maybe something like that. 0 to 1. And we take the same color bar, maybe. And hide it. So, good. Surface baffles. What's that? 1, 2, 3. They should be some preset materials. And for the preset materials, we need to import some more preset materials. Because preset materials are literally my job. And I have 7 tons of them. Import in my CCM visual templates. Rendering materials. Okay. So my preset material should be metal, aluminium rim. Yeah, that sounds decent. And surface drum will be a preset material, namely stainless steel. aka tungsten. And what do we have for unsuited backgrounds for this? CCM visual templates, environment maps, spheres. Yeah, I guess unless we have something better, we could place our washing machine in our gray building. Factory. Ah, here we have building gray. Again. Yep. Oh, we have the moon here. I can... Or do you think we can put our washing machine in this environment better? Or in the studio room? Let's start with a gray building. So I make a new folder. Buildings. Gray. Fair hall is somewhere else. Corridor, hospital, studio room, chapel, old hall. Yeah, let's move them there so we have it easier. I could even place it in the Leuven factory. Okay, so let's do this. Environment maps. Environment maps. Spherical. We call it the building now. And we take this from environment maps, spheres, buildings, building gray. That's a Polish building. Okay. -10090. And it works. No, more or less. That's a classroom. I never noticed. Crazy. So what else do we have here? Spheres, buildings, large corridor, maybe. Not details. View, preview plane. Does it fit into a corridor? No, I don't think so. Hospital is dumb. Yeah, okay, let's put it in the studio room then. Okay. Good. Then we need some shadows for all our displayers. I will just let it iterate and get rid of my sweatshirt and come back in a minute or something, okay? I will clear the solution for now. And what did I put in the particle velocity? It is, and contact relative velocity magnitude. I need to include this into the history. Particle velocity, okay, it's in there. Parcel index, okay. Contact. Okay, I need a new one, I guess. Contacts. It will be called, and we will have contact relative velocity magnitude here, and we will have it phase interactions particle wall. So let's go enjoy the show. See you in a minute. Hello, 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 I'm back. Time to stop our history here and see what we can do. Surface baffles have material now, surface drum has material, and surface front has material, yes. So let's just turn on advanced render. Ooh, my... It seems like we have overlapping materials here, don't we? Oh no, that's just reflections from the glass. Okay. So first of all, the towels need to be matte material here. Right? They don't have any clear coat on them. They shouldn't have. But I don't like the glass. It's too reflective for my liking. So that's why I will make a different transparent body. And of course you won't use glass here, so this is like a plastic body. You would rather likely use PMMA or something. Yes, we will use this one as the front. Drum, front, yes. Glass body, no, not glass body. This one here. What happens if I change this? Yeah, might be actually better, a little bit. Just because now you can see inside. And you still have that impression of glass. But I suppose there is a front door to this. The door, yes. Maybe like that. So what we are doing next is we are using our scalar contacts. By the way, I'm just putting this one further down the road. Somewhere here. So I can have it below. And I will turn this into light emitting. And as you can see, you can't see anything. Okay, there's literally no light. Better. No, let's keep it with that. Or maybe we can say scalar and then say not parcel size, but just the same. No, I'm not. I don't. Let's keep it with particle model. and then say 0 here. So let's light up the scene. With our drum contacts. Can we? Not really, I think. Holy moly, what's wrong here? Point 5, 0.5. That's gonna be a wonderful drum. Maybe we should add a little bit of clear coat here. Nah. That doesn't change anything. But we should definitely install a light over here. Don't you think so? Let's install a light. Making another light here means we need a geometry. New shape part. It will be a cylinder. So I need some guidings where, okay, Y is my rotation axis, minus 0.1 to, this will be 10 millimeter, to 0 here, 0.1. Okay. But let's put it in the top right, so make it 0.1 here, 0.1, 0.1, 0.1. There. Damn. 0.1. Minus 0.1. 0.1. Yeah. Okay. Create, close. This one will be the light. So we need a new surface displayer, calling it light. This one should have the representation geometry and will be constant. It will be white. It will be no, it won't have shadows. It will be light emitting. Come on, emit harder, please. Zero opacity. I guess we need to turn down the IOR, the index of refraction, for that plastic stuff. Just because, not because it doesn't look real then, but just because you need to see that there is some glass door, but you don't really need to see how big that one is, right? That's an issue. Your image gets completely blurred out with this one here. That's better. That's way better. But I don't like the aluminum rims for the baffles. Let's see if we have another metal. Black chrome. They could also be like plastic, couldn't they? Just like black rubber or something. Because in my dryer they are not even metal. They are more like this. Or if dark rubber is not fine, I also have that display that's called tire. I cannot deny that I came from an automotive background. Can I? You won't believe if I did. Okay. Okay, so let us clean up, shall we? Because I want to make a bigger scene of that. I want to have 3 machines in a row starting at a different time. So let's see, what interesting field functions do we record here? What do you think? I want to have 3 machines side by side, and I want all 3 machines to show something different. Like one machine showing particle velocity, second machine showing another quantity, or maybe first machine showing the towel index, right? Just like towel 1, 2, 3, which it did at the start. So let's save this. So we duplicate this one here first. Towel velocity. Calling this one the 10. So starting here, cleaning up. This one is 99 lights. Nobody needs that later. That one is the 11 contact velocity. This one is number 90 baffles. This one is 91 baffle. Ah, no, it's drum. And this one is 98, or yeah, maybe front. Refresh. Good. Fine for me. Save it. So next one, no, I need this one here. Duplicating it to number 12. 12 towel index. I guess it was towel index, wasn't it? So and this one goes to the 20 section. Maybe 20 exact. And this one can go. Refresh. Towel index we had first, I guess. I can swear it was something like towel index. Come on, I need to get rid of this here. Don't show it. This one doesn't have a shadow, please. And this one won't have a shadow, please. Okay. Parameters, rotation, towel index it was called. Okay. Towel index. What colors are our towels? Shall we have Siemens towels? I guess that's like the best option. Yeah. Okay. Solution histories. Now the contacts, that's fine. So what did we record? Component size, towel index, velocity. What else could be interesting? Particle okay, let's check our physics, what we do have here. Multi-phase interaction. Okay, now that's not models. Passive scalar we do have. It's Flyo. Hey, welcome back. Should we expect any Eintopf steering simulation soon? Well, I don't know. The learned machine, he just needed support while microwaving. This is why we started this simulation, to help him with the household. Yeah, food is another opportunity for awesome simulations, I suppose. But this one is towel drying first. So yeah, let's see what we can do here. What is this towel index is a passive scalar. That's interesting. Yeah, that's interesting as well. See, it's even modeled as cotton. Holy moly. Okay. Do we have any interesting feed functions here? Depletion, we have no depletion here. Contact elastic force. Let's see. Oh yes, we could maybe duplicate this one here. And refresh it. Naming it. Well, what did I do? I pressed F1. Okay, naming it 13 contact force P particle, and let's see. So we go for contact force magnitude, maybe. Okay, that's like nothing here. Did I choose a... I chose a linear scale. Okay, that's interesting. Can we choose a logarithmic scale for once? We have forces in this here. Is it different to when if I show force, elastic force? Now that's only valid for particle contacts. Okay, so this one could be this here. Right? With like 0.15 and 0.15 e minus 4. Something like that. But we need to turn this around. No. High contact forces must be red. And Siemens is not the color bar that we want here. Maybe we want this. Maybe we want that. Well, no, we don't want that. Maybe we want this here. No, we don't. Okay. So do we have mechanical stress? I had some Siemens stress. That's what I already use for fire. Advanced logarithmic. No. Yeah, let's use this here. And. So 0.1. And 1e minus 4. Okay. Okay, that's contact forces. So basically we are answering the question here, is your washing machine ripping your socks apart? The answer is no. Yeah, I think that's it. So let's make 3 out of them. I don't know who placed the dryer in the kitchen. I will later put it back into the basement, but for now we need to keep it here. That's my kitchen. I could place it here, but that's most likely as unsuitable. Do you want to have it in the corridor? This looks like a schoolroom if you open it up, so that's also unfit. Maybe we can find another place to store it for now. No, I don't think so. We could let our colleagues work on this. I'll just place it in the foyer at the factory. What else do we have here? That's old motors. Tunnels. Yeah, let's maybe take this one here. White Studio. The holes in your socks are not... No, they are not your dryer's fault. They are your washing machine's fault. Because washing is far more aggressive for your socks than drying them. You only see like all the fibers coming out in the dryer, but they are not produced in the dryer. They just get separated from the thing in the dryer. The building. Here we are. Yeah, I had to work on this professionally. Seems ridiculous, but I did my master thesis on... Oh yeah, that's better. I did my master thesis on microplastics filters for washing machines. And actually, yes. Maybe buy better socks then first. But where was I? I don't know. Yes. Stands on the side. So let's put the dryer 3 times here. Transform. Simple transform. Graphics periodic repeat. Number of repeats 3. Yes. Scale. Periodic repeat. Simple transform. Translation, here we go. So Y is that direction, Z is that direction, so we need a meter. Or let's say 0.65 meters in X direction. 3 dryers. And have them 3 dryers side by side. No, I can't count. I can't count. 2 repeats means 3 dryers. Yes. Okay. Simple transform. Second dryer. No, dryer 1 will be translation 6.5, and the next one will be dryer 2. Maybe you ask, why don't I start counting at why don't I say 2 and 3? Because the first one is number 0. Here we go. Ah, this one should also be 3 dryers. No, wrong one. This one goes to the last one. I wanted this here. Today I totally misclick. That's like the lighting. Wherever I have a contact, I have a lighting. So towel index. That's my first one. Dryer 2. Not dryer 1. Come on. Okay. Now we just need to sort it out. So towel velocity is this one here. This one needs a different color bar, definitely. Towel velocity will be, I need a horizontal color bar, definite horizontal. And it goes to a width of 0.2, yeah, that's fine. And I will place it at a height of 0.7. And it will be 0.4. Yeah, I know. 0.4. Particle velocity. A little bit higher, maybe. Preceding. Then I can put it a little bit lower. And the text will be smaller. And this one will be smaller. And this one will be smaller. Yeah, that's nice. 0.2, 0.2, 0.2, 0.2. 0.2. So horizontal. I can make the changes on both at the same time. Preceding. Horizontal. Width 0.2. 0.2. 0.02. First of all, it should be here, starting here. And then it is like 0.02, 0.02, and point O2. And the right side is contact force. So this will be 7.5. Hello. Ooh, it's almost 5 p.m. at my place. Just give me a second. And the solution time needs to go. Annotations. Bye 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 bye. Okay. The view 001. I don't yet like this colors here. But maybe that's okay for now. This one needs to go for towel index. This color bar only has 5. And the right one needs to be changed. Contact force, color bar. So we have blue, red, yellow, white here already. So that's unsuitable. Maybe we can use something like this. Green to orange. Yeah, that works better. At least there is a distinction between them, right? Okay. So contact force magnitude I need to add in here. Regions, baffle, 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 door, front, drum wall. The back has a different color. That's great. That's great. I can. So first of all, I will leave the back out here, the door and the front. Okay. And then I will duplicate the drum because the back is independent. 92 back, and this one will be removed from here, and this one will be removed from here, so I can apply a different material. What happens if I just apply aluminum? That's just the back. Yeah, that just gives another impression, doesn't it? Yeah, I think I like it better. Okay, so let's turn this off. Let's, just for a test, turn this off. Let's see what I have here. Parcel, I don't need the parcel index. Oh, damn. So parcel, I don't need the parcel index. Bonded component, don't need. That's fine. Saving it as towel 02. Because it's one of the most useful things an engineer can have. Sorry for that. Yeah. Can you have an eye on my laundry while I take my dog out? She just needs to go for a minute or so. So I will be back very, very soon. And when I'm back, I will think about how to make these 3 drums rotate independently. I'm already thinking about this, but let me think about this further. So let's just check how big the file is going to be. It's tiny. Okay. See you in a minute. Need to take my dog outside. Please watch my laundry. So I am back. Let's stop this. Perfect. So my idea is to let these three drums run independently. Let the particles settle at the same time. And then have three independently running drums. Let's just check. It's ridiculous how small these data are. The context is like 2.5 megabytes. And the towel is like 113 megabytes. That's like nothing. I recently recorded a simulation that had like 1.2 terabytes in history. So no. No. Okay. Drum 0. Drum 1. Where? Drum 2. C0. C1. Where? C2. Okay. First of all, I need to duplicate these ones here, I guess. Refresh. So the back will be 97. 90 baffles and drum. And refresh. That's 91 then. That's 92 then. That's 91 then. 91 drum. That's 92. Okay. So these here will be dryer 2. These here will be dryer 1. And these here will be identity. Okay. This one will have drum 0, as will the towel index. That's 0. That's 11. And that's 12. And I will have to duplicate this one here as well. Contact velocity 20, 21, and 22. This one will be dryer 2. No. Dryer 1 and identity. So this one will have the representation C0. contact velocity. This one will be C1 and this one will be C2. This one, that one, and that one the hell? What the hell? Yeah, we'll have the representation. What? No. We'll have the representation D0. Right. This one, that one, and that one will have the representation D1. Right. This one, that one, and that one will have the representation D2. Right. And now it is time to create 3 dryers, a screenplay, which will then make these two state index, state index, and state index. Okay. Let's dryer 0, dryer 1, dryer 2. Okay. We have 280 states and each 0.5 seconds. Okay. And how many steps will we make? Stopping criteria. Maximum physical time, 5 seconds. So we will have 1,000 steps, which then will be enough to for 16. So we are starting at 0 and it will be 16.667 seconds then, because we are recording 60 frames per second and we will have a stop time of like 1 frame. Okay, so state index will be 1000 here for this one at least. So when I do this, we don't start the rotation before we start the rotation before it's all fallen down. Phase 1 custom tree. Okay, parameters, motion start after 0.2. Shall we wait 0.5 seconds? Or shall we wait a full second until it has fallen down? towel interval time 0.5 seconds. So here, somewhere around here, the last towel has fallen down. Yes, half a second should be fine. Motion start. I hope I'm not ruining everything now. Motion ramp, okay. Hey! Geh auf deinen Platz. Okay, half a second. Half a second in time steps is let's make things easier to calculate. Let's tune it up to 100 frames per second and make these 10 seconds, maybe, yeah, make these 10 seconds long. Good. So I have like no, wait. I have 100 states in half a second. So I need to make this 200 frames and 5 seconds only. So I can increase this even further. Yeah, and say, okay, here. Okay, I will add a new keyframe at 0.1 and say its value 100. And copy this here. And paste it again. And say it will wait like this. Pasting it here. Making it there. Okay. And then we iterate up to 900. And here we iterate up to 800. Yeah, that's nice. That's decent, I think. But I will make the stopping criterion (10 seconds). So I can increase this here to 10 seconds. So I can make these states here. This will be 2000 then. And this one will be 0.05 then. And this one will be 0.1 then. And this one will be 1900 then. And this one will be 0.05 then. This one will be 0.15 then. And this one will be 1800 then. And I think that will be quite nice. So I have like 3 shifts where it falls down. Yeah. So let's save it. And let's clear it. Okay. "29 states already. Good. 30. So I need at least 100 states. And then I'm happy if it runs up to 100. So I think the next task would be adding some air and some steam in here. I've done this before, but or at least a specialist has done this before for me. And I'm sure he can do this again. 91. It's just nice that it's so fast. And so small, actually. It's ridiculous. And it's not even compressed. Okay. Let's stop here for a second. And where is my screenplay? So we start here. We start here. We let this fall down. Everything's settled, right? Particle velocity has turned to 0. And then this starts, and then this starts. Okay. Cool. I'm happy. So how many do we need? We need 300, I guess, before we can have all three drums running. So let me just do something on the side until we can watch the first 300 states. Okay, 158. Holy moly, what's going on in my... Okay. So we already have 200 iterations now, or 200 time steps. What the? What happened here? Please don't tell me that it has issues. Don't have issues, please. I need... First one is tumbling. So it was 100 here, 200 here, we need 300 plus. Yeah, that's 2. Let's go. Nothing has gone wrong yet. $250. It doesn't help if it is the fastest simulation on Earth. If you are waiting for results like I'm doing right now, it can't be fast enough. Really, it cannot. $60 more iterations until we can call it a day. Okay, 30 more. $20. Come on. I just want to have one single picture as a result of today. Why does it keep trying to inject? I haven't fully understood, but that's okay. I'm just the marketing guy. I don't need to understand everything of this from this simulation. No, I wanted 14 states. Never mind. So the first one is rotating, the second one is starting. Yeah, the issue is you can't really tell the different sheets apart, can you? Maybe you can. Let's show the front and turn it on. I guess that's what you call a fail. Damn. Yep. Yep. So we need this here. And we need to work on this one here, because that one needs to go. And that one needs to go. And this one then is 18 seconds, starting at 2. of course it's not. It's 9 seconds. And this one is 9.5 seconds, starting at 0.5. And I can delete everything. So I guess that's it for today. I will just let the simulation. Shall I let the simulation run? No, I will just let the simulation run after the stream, if you don't mind. Okay? So I thank you very much for tuning in today. I hope you liked what I did with my laundry. I hope to see you next time again, and see you soon. Bye bye.